Good afternoon, lovely humans. Today we're going to be going over the second half of 10.1.1, so problems 10.4 to 10.6. We're going to be talking more about arithmetic series. So remember, a sequence is a list of numbers. Goodbye, pen cap. Is a list of numbers, let's say like 2, 5, 8, 11, and so on. That's a sequence. The corresponding arithmetic series for the first four terms would be 2 plus 5 plus 8 plus 11. And that's kind of what we learned about yesterday. We also learned about a technique that can help us quickly calculate series by pairing up certain numbers together. Okay, so 10-4a, I'd like you to take a look at it. There's going to be a situation. You're going to have to write an equation and take a look more at that pattern that we talked about before. So 10-4, A, B, C, D. I'll be back to go over it. Welcome back. So let's go over 10-4. Part A, you want to come up with an equation in first term form. So T of n is equal to the common difference, in this case, which is 2. And that is the number of meters gained compared to the previous second. So the amount of meters added between each second compared to the previous one. You might also think about it as acceleration, so the meters per second squared, because it's kind of like each part represents a speed in a meter per the 1 second. And then you're comparing it to seconds, so meters per second, meters per second squared. So for those of you that are in physics, that is acceleration. And then plus the first term, which is 1, and that's the meters traveled in the first second. Okay. Parts B and C, so if you add them all up, what are you going to get? Well, that's going to be the total distance that she travels in 6 seconds. So you travel 1 meter in the first second, and then 3, and then 5, you will have gone 1 plus 3 plus 5 meters. And then looking at this visual, just to help us relate it back to the context, so each of these columns represents the distance traveled within that second, and the total number of tiles is going to be the total distance traveled, right? So if you add these all up, you will get the total distance traveled. So what we want to do is think about combining this into one big rectangle, so similar to what we were doing before, except more visually. So let's take this tile and put it up here. And then if we take these 3 tiles and put them here, and finally if we take these 5 tiles and put them here, then we will get a rectangle, right? So similarly to how we paired them before, you kind of paired up the first and last number, the second and fifth number, and then the third and fourth. You will get a 3 by 12 rectangle, which is easy to calculate as 36 meters. So using this idea, that should be super helpful for you as you do 10-5, A, B, C, and D. I'm going to ask you to just look at part A, and then we'll go over it, and then you can, once you have an idea what's going on, you can do parts B, C, and D. Go over parts A and B, because A is kind of like a weirdly easy one. So parts A and B, try those for yourself. I'll go over those, and then you can do C and D. Alright, welcome back. Let's go over A and B. Part A is just a 5 by 7 rectangle, right? So how do we calculate that? Well, we take the height of the rectangle, 5, multiply it by 7 to get 35. Remember, we have to add together all the values. Part B is going to require the use of the pattern that we talked about in the previous problem. So creating one rectangle. So if this first height is 4, we're going to put that here instead to make a size 14 column. If this size here is like 4.5, we can put it here with 9.5 and 4.5 to make another size 14 column. And continuing on, right, we can keep doing that. So we can put this 5 here to make another 14. And all in all, we started with 16. We pair them off into groups of 2. So we end up with a 14 by 8 rectangle, getting us 112 as the result of our series. With that, please try part C and D. We'll be going over them soon. Whoa! Okay, so here's the results for 10-5C and D. For 10-5C, we had a first term of 228 and a last term of 48. And so we put those two together to make a rectangle. We put all the other ones together to make rectangles of the same height. To get one big rectangle that has a base of 3, right? That's half of the number of terms. And then we can get our answer. So if you do that, you should get 128. And the same thing over here. They did tell us that the height of our first column was 14. The height of the last one is 20. And then the total distance was 32. And so that means that we're going to end up with a 16 base rectangle once we've smushed and paired off all the columns. And so we end up with 34 times 16, which is going to give us 544 as the result of our series. Okay. So that's that. Hopefully that helped you see that pattern we were talking about in the previous lesson in a different way. Same idea of pairing off terms to make our calculation of the series a little bit more simple, or at least shorter. So go ahead and try now 10-6. Remember, you don't have to use this pattern or this shortcut to find the answers. In fact, sometimes it just makes more work for yourself. So keep that in mind. Try to come up with what the series is, and then you can just add up all the numbers. Last problem, here we go. Part A, they tell us that the first term is 18, the last one is 72, and we are growing by 4.5, so let's just add it all up. So 18 plus 4.5, 22.5. Add 4.5 again, we get 27. Add 4.5 again, we get 31.5, and keep going all that way until you get to 72. That's the easiest way to do it. Just add them up, you get 585. Part B is a little bit trickier because they don't tell you the common difference. They don't even tell you the last term. So what we want to do is we want to remember this pattern that we found. So the first term and the last term, right? So they combine to make one big number that ends up being the same as all the other numbers paired together, right? So like the first and the sixth, and the second and the fifth, and the third and the fourth all end up with this sum. And then the base, we end up multiplying that. Once we've paired them all off, it ends up being half the total number of terms, and we get the sum of our series. So let's plug in what they gave us. They told us that the first term was 21. They told us that the number of terms was 6, and they told us that the sum was 336. So let's solve for that last term. So this is equal to 3, so let's divide by 3 on both sides. So we get 21 plus x equals 112, which means that x is equal to 91. So now we have our last term. And so now we need to write like what the values are. So we also need to know what the common difference is. So if we start, we can kind of do like a delta y over delta x thing. So if our last term is 91 and our first was 21 and this was the sixth term and this was the first term, we end up with a common difference of 14. And with that, you have enough information to write your sequence. So I'll write it in a different color over here. You end up with 21 plus 35 plus 49 plus 63 plus 77 plus 91. Whew. Okay, part C, not enough information. Yay, we don't have to do anything because we can't. And then part D, they tell us the third term, they tell us the common difference, and then they tell us how many terms there are, which is plenty of information for us. So what we can do, if we know we're adding by 10 going forward, go back to find 19 and 9 as the first two terms. And then just keep going. We're going to add 39 plus 49. Sorry, we want to write this as a series, not a sequence, so let's add them. No commas. Plus 59 all the way, you're going to end up plus 179 to get 18 terms, and that would be your series. You should get a sum of 1,692. And that's all. Have a great rest of your day.